Hello all, let's start with our today's DSA journey with this amazing ChaiCode visualizer, that is Chai Visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial on this platform. Go here, go to array and hashing, go to the next element, that is valid anagram. Okay, same letter, same count. That is the main motto. Given to string S and T, return true if an anagram of S. If T is an anagram of S. What is anagram? A rearrangement using all original letters exactly one. This is the tag. Okay, so here actually there is a some problem in this simulation, so T is not visible here. So we just go to just to the question on the lead code and let's see it here also. Okay, just so these two are string, they are anagram, and anagram means a rearrangement using all original letter exactly once. Okay, so how, just check it. So these two are string. Okay, two string. First check, a is here. Is there any a? A is here. N is here. N is here. Again one a is here. One a is here. G is here. G is here. R is here. R is here. Again one a is here. One a is here. M is here. M is here. Okay, so every element of this or every character of this string, we just take it, we just take every character from this string, rearrange it, just we rearrange it and make the another string. We don't use any extra string or we don't reduce the string. Okay, so these two are anagram. On the same example, like here, rat and car. Okay, so no, rat and car. So you can clearly see here, like R is here, yes R is here, A is here, yes A is here, T is here, no T is here. So this is not an anagram, but this is an anagram because we take every element from this string, we rearrange this and we get this new string. For this reason, this is anagram and this is not an anagram. So how could we find that? Okay, so first take these two again. Okay, so these two are two string. How could we actually do it? Let's suppose just can we just sort this string, like sort in the basis of character. So a a a 3a will be come at the front, then a g, then m, then n, then r. So 3a at the starting, then G, then M, then N, then R. So we sorted it alphabetically order. Again, the next string, which is T string. So this is A string and this is T string. So just again sort this string also. Like 3a, 3a. Here also 3a, then a G, then a, okay. Then a G, then M, then N, then R. You can clearly see these two strings are same when we sorted both of them. Like we sorted both of them, we get a same string. Same string. We sorted both of them, we got a same string. So if we sorted and got a same string, we just return it as true, otherwise return it as false. You can clearly see here, like rat and cat, rat and car. Just check it, like it will become a r t. Okay, and this will become a c r. So these two are not equal. So these are not valid anagram, but these two are equal. So this is valid anagram. So sort it. Sort. Sorting is give us the actual answer. Here also T is an anagram of S. Use the exact same letter, same count. Okay. Simple idea. Sort both of the string. Compare sort of S and sort of T. Okay. Just compare it and we get a time. Okay. So just now write the pseudocode here. That is function S and T, both string we are given into the function. So return just a simple sorted of S equal to sorted of T. If we just returned it, it should work. Yes, we nailed it. So just go to the question, paste the pseudocode here. So this is our first. Take the S and sort the string S. Okay, so S dot begin and S dot end. Using this line, it sort the string S. Okay, and now sort the string T in the similar way. T dot begin and T dot end. Okay, now return S equal T. Okay, that's mean if both are equal, then it should return true. If both are not equal, it return false. So just run it. Okay, it works. So the time complexity of this solution will become big O of n log n because sorting takes n log n time, and the space will become big O of n because in the base case sorting the time complexity would be big O of n log n and the space complexity will become big O of n. Okay, so now just go to the optimized map approach. Okay, so for the map approach, these two string, suppose we take a map. Okay, we take a map. We just take a map here, and the map contained two things. One is character, another one is count of the character or that stored in a integer. So this will be a character and this will become the count that would be in integer. So now just traverse this string. So first character become A. So A here. What is the count of the A? 1 or 1 here. Then N. Then go to N. What is the count? 1. Then again A. Increase it by 1. G. 1. G becomes 1. Now R. R becomes 1. Now again A. Increase the A by 1. It becomes 3. M. Okay. So M. M became 1. We just complete this string. Now traverse this second string. N. So go and remove 1 from the N. A. Remove. G. Remove 1. A. Again remove 1. R. Remove 1. A. Remove 1. M. Remove 1. After completing this string, the second string or the T string, the map contain every character as 0. That's mean the both of them are anagram, because and in the first string is we just increasing the value of every element, and the second string t we just decreasing the value of every element. So if both of them contain the same character and same number of time, then the map at the end should become 0. That is become here, everything becomes 0. Okay, everything becomes 0. So that is the main optimized approach of doing this using map. That is, first take the a string, or you can do it with t also, but let's take the s. Take the a string, for every character in the string increase their count and store it in the map. Okay, then go to the another string, that is t string. In the t string, for every character just remove the count from the map, and when you remove the count from the map, at the end the map content only 0. The count of all element is become 0. So if any of them store more than 0 element or less than 0 element, it will become not an anagram. Why? Because if someone has another m here, so it the m become -1 and it will not become an anagram. Okay, so that is the reason. So in the next string, whatever we do, we just negative it. Okay, so if suppose here one t is here. Okay, so here is not t. So if we go there, we just take one t. So we also do it in another way. That is, we put one here. So at the end, we cannot do it this t, but this will change. Also, at the starting we have to check the size of the string. Suppose we don't have to do this t thing here, just suppose t is here, so the size of the s is greater than the size of the t. For this reason it will always be false. Okay, so even not greater if the size of the string t and not equal to s, that's mean both of them, the size of both of them are not equal. If the size of both of them are not equal, how can they become the equal number of element? They can't. So for that reason, at the starting we just check this condition. If the size of the s and size of the t are not equal, then we just return false at the starting, because if the size are not equal, then how could we uh, uh, become the string as anagram? Okay, so even at the end we just, for when we add this condition, we just have to add one character, one sorry, not character, the one's if statement at the, when we are reducing it at the tree, that if any time, suppose here we have another like c. Okay, so first remove this. Okay, okay, remove this t. We have another character c here. We just push go and see that there is no c, so put c, and the hash map rule is we just put c and make the count as initialize with 0. Then again we are removing this, so it just go there and make it -1. Whenever we got a element with -1, we just, at that point we just go and return false. Okay, so let's just take that example, that is rat and car. Okay. That is car. So these two are not anagram, but let's dry run it with the map approach. Okay, so just take a map with two things, character and okay, character and the um, character and the count of that character. Okay, character and the count of that character. So here is character and here is integer, which is nothing but character count of that character. So first go to this r. Okay, so r is here 1, then go this a, so go to a is here 1, then go to t, so t is here and become 1. Now go to here c, so there is no c, we just put c here and remove it, so it become, first it initialize with 0. So actually everything at the start initialize with 0. In the hash map, everything at the start initialize with 0, then we just increase it by 1 using a simple plus plus. So in the case of C, we just increase it, we just take C is not present, go and insert C, at the end just remove 1, like 0 minus 1, that is minus 1. In any time we get a minus 1, we get a minus 1, that's mean this is a false statement, so we just remove these, both are not anagram. Okay, so this will become, so we have to use this condition at the starting and this condition at when we are removing or reducing element from the map. Okay, let's visualize it first. So here see, count of a equal to 1, n equal to 1, a become 2, a g become 1, r become 1. Okay, okay, a became 3, then m became 1. Okay, now go to and remove it, so n became 0. Okay, you can go to here, count is 0, then a, the count reduces to 2, then go to g, the count reduces to 0, then go to a, count reduces to 1, then go to r, count reduces to 0, then go to a, decrement and count reduces to 0, go to m and count reduces to 0. If everything is 0, we return true. Okay, so first write the pseudocode here. So we are taking a function, it take s and t, two string, so we take map. So at the first check if uh, the length of s is not equal to the length of t. If this is happen, just return false, because if both are not, the size are not equal, we cannot prove it anagram. Okay, so checking the size, now character, this will be a char comma int pair. We just take it as a character comma integer pair, and the integer is the character count of this character. Okay, so now take a for loop. So for every character in s, for every character in s, just do map of that character and increase the character. Okay, and then for character in t, for every character just reduce the character, just reduce the character. Okay, and here also if any condition, the map of character, or the count of the character become less than 0, at this point return false, because when it become less than 0, that's mean we cannot move further and these both are not valid anagrams, and at the end just return true. If all the cases false, it should work. Okay, let's go and check it. Okay, just go here. Okay, now write the optimal solution for this code, or for this question. First take okay, first check the if condition, that size are not equal to this. If s dot size is not equal to t dot size, if it is happening, then simply return false, simply return false. And now take a map of character comma integer. Okay, this is just character and count in a map. Okay, we just take this map, character and the count of that character in this string. Okay, so for character in s, okay, for character in s, just put map of character plus plus. Okay, and for character in t, for every character in t, we just reduce the character and check the condition. If map of character, the map of character become less than 0, just return false. Just return false. If it become less than 0, if all of the condition is not satisfied, then at the end return true. At the end return true. Let's just check it. Okay, it works. It works. So here we just uses two loops, like one loop for traversing s, another loop for traversing t, and we do, if the size are not equal, we don't traverse. So the time complexity would become big O of n, and we are using a map. You can say big O of n, but we are reducing every element from the map, so at the end the map will become empty. So it space complexity will become big O of 1, but also you can say big O of n also. So the time complexity would become big O of n and the space complexity will become big O of 1. So that is the question valid anagram. Okay, go use this platform, use this link to get a 7-day free trial. Okay, use this platform at dsa.chaicode.com. Thank you very much.